Today we're going to do a couple of weight calculation problems. So the first problem we have is if a person has a mass of 55 kilograms, what is his weight on Earth? So to solve these problems, we'll use our typical problem-solving method of Donkey Kong eats stray cats. So our first step is to draw a picture. Might seem kind of silly, but as we go and we keep solving more and more complex problems, drawing a picture will be more and more important. So I've got a person, and because we're caring about weight, maybe my person is on a scale. My next step is to record my knowns and unknowns. Well, looking at the problem, I see I have a mass of 55 kilograms. So I can write M equals 55 kilograms. And I want to know the weight. So I'll say weight is question mark. Now in order to solve this problem, I need one more piece of information. And then that has to do with the fact that we're on Earth. On Earth, acceleration due to gravity, or G, is 9.8 meters per second squared. My next step in the problem-solving method is to write my equation. My equation for weight is that weight is mass times acceleration due to gravity. My next step is solve symbolically first. So looking here, I want to know weight, I know my mass, I know my acceleration due to gravity, so my problem is actually already solved. So weight, mass, times acceleration due to gravity. So I can plug in my mass of 55 kilograms times my acceleration due to gravity, 9.8 meters per second squared. Enter this in my calculator, and I will get 539. Now we're on to our final step. Our final step is to check your answer. So looking here, one thing we need to consider is significant figures. Now this 9.8 is a constant, so we're not going to use that to determine significant figures. We will look at 55 though. 55 has 1, 2 significant figures, so our answer should have 2. So we'll write 5, round the 3 up to a 4, and then because this is in the 500s, our answer can't be 54, it must be 540. And our units for weight are the same as force, because weight is a type of force. Our units are newtons, so our final answer is 540 newtons. Now let's do a trickier problem. So this second problem says my dog has a mass of 25 pounds, where 2.2 lb, that's the abbreviation for pounds, is equal to 1 kilogram. And I want to know, what is my dog's weight in newtons? So in order to solve this problem, I'll use the same problem-solving method. So I'll draw a picture. And again, I know I'm not the best artist, but this will help us as we keep going. So here I've got my dog. It's very excited, Daisy. My next step then is to record my knowns and unknowns. So looking at this problem, I see I have a mass of 25 pounds. I'm going to use that abbreviation LB. My dog's on Earth, so I know my acceleration, 9.8 meters per second squared. So G equals 9.8 meters per second squared. And I want to know my weight. Now the only problem is, before I start solving as I did up here with the equation, is that my mass isn't in kilograms, it's in pounds. So I need to do fence post. I know you were hoping those were over. So to set this up, I have 25 pounds, and I want to get rid of pounds and go to kilograms. So I'll put pounds, or LB, on the bottom. Now I have up here that 2.2 pounds is equal to 1 kilogram. So that's what I'll set up as my fence post, because this is like multiplying by 1. So 1 kilogram over 2.2 pounds. These units will cancel, my pound units will cancel, and if I put this in my calculator, I have 25 times 1 divided by 2.2, and I end up with about 11.36 kilograms. Right, here's my unit kilograms. So I'll just write this up here. My next step then in the problem-solving method is to write my equation. My equation is that weight is mass times acceleration due to gravity, or g. Next step, solve symbolically first. Again, it's already solved for W for me. So W, or weight, equals mass times g. So I'll plug in my mass. Now I can't use the 25, I need to use it in kilograms. So 11.36 times 9.8. And I put that in my calculator. And I get 111.3636. Now my last step is to check my answer. So looking here, I'm not going to have all those crazy decimals, right, with significant figures. I want to go back to not these numbers in here, but back to my original problem. So the number I was given, 25, has 2 significant figures. So my answer should have 2 significant figures. So I'm going to write 1, 1, placeholder 0, because 111, this needs to be 110, close to 111. And then my units are newtons. So 110 newtons is how much my dog weighs.